Unity Water is proud to sponsor this podcast series because we believe great news, great solutions and great outcomes deserve to be shared. See what we're all about at unitywater.com. You're listening to the Australian Water Association's podcast series.
I'm Hazel Flynn, and with me now are Dr. John Knott, Associate Research Fellow at the University of Wollongong, and Dr. Bustamante, Principal Scientist, Treatment at Sydney Water. And they're talking about a study that they undertook about some interesting storage solutions. So, John, this study was undertaken as part of the Smart Sodium Storage Solution project. Set the scene by telling us a little bit about the project and its aims.
Not a problem. So this work was undertaken as part of the Smart Sodium Storage Solution project, as you mentioned. That's a $10.5 million ARENA-funded project, and it's looking at developing sodium-ion batteries, but not only developing the research and the technology around them, but also developing the manufacturing capability and manufacturing capacity, and then demonstrating these batteries in real-world applications. So we've got not only sort of the university research, but also the industry, manufacturing industry coming along with us, and then we have Sydney Water as our end-user application here, really driving a lot of the decisions and a lot of the engineering areas that we're looking into in order to make sure that these sodium-ion batteries and the energy management system that we build to sort of manage that energy usage and storage and consumption, we need to make sure that that is meeting Sydney Water's needs.
And Harry, this is an important project going forward because pumping fresh and wastewater uses a very significant amount of energy, doesn't it?
Yes. Sydney Water uses around 400 gigawatts per year. Every year, and around 40% is because of wastewater pumping stations. Now, Sydney Water is very committed to using renewables into its operations, but there is an issue there that we don't have, for instance, sun. The solar panels don't work constantly, so we need to have a system where we can store the energy such that the pumping station can use it. So that's why we came into this project. Sydney Water uses around 160 gigawatts per hour per year, which is a substantial just pumping wastewater. Sydney Water also has around 680 pumping stations distributed over an area of around 12,000 square kilometers. And many of these pumping stations are in remote areas that can be left off the grid when there are storms or there are bushfires or there are heavy rain events. Therefore, it is essential that we have ways of still getting the pumping stations to work, and this is why we are involved in this project with the University of Wollongong.
Absolutely. Well, that 40% energy use is a great incentive to look at different ways of doing things.
Yes.
And then, as you say, sewage pumping systems need to stay online no matter what.
No matter what.
Electricity goes out, they need to be online. There's a bushfire, they still need to be online.
Yes.
So you need a different way of doing things.
This is also, Sydney Water needs to improve its resilience. One thing is to reduce the electricity consumption, but also increasing the resilience.
Yes, that resilience is so important. And John, you tested out the possibility of a sodium-ion battery-based energy storage system. Tell us about the site you chose and how the experiment unfolded.
Yeah, so this is a very unique project in that we're testing sodium-ion batteries, or we're developing sodium-ion batteries rather than lithium-ion batteries. So your phone, your electric vehicle, even up to the big Tesla battery down in South Australia, they're all lithium-based. And there's some issues with using lithium around the scarcity, just the simple scarcity of lithium and cobalt and nickel and all those materials that go into these lithium-ion batteries. So we're looking to sidestep that by developing these sodium-ion batteries. And as you said, we needed to find a real application where we could show the benefits that these sodium ion batteries could give. So we were partnered with Sydney Water, and they together we've selected this site at Bondi. So the Bondi sewage pumping station is just off Bondi Beach, about 100 metres from the Pacific Ocean, so right near some sodium right there. And we're looking at not only putting a sodium ion battery in there, but you can't just have the battery sort of and that's it. You need to think about, okay, as Harry mentioned, we need some solar panels. We need a way of looking at, when the sun's shining, do we use that energy straight away in the pumping operations? Do we store it for later in these sodium ion batteries? Do we sell it back to the grid? All of these sorts of ways that the energy flows in and out of the system, we need to develop a way of making sure that that's the optimal way of using that, and also keeping that resilience in mind. So, if we're selling power to the grid now, what happens if it goes out? If we just emptied all our batteries? Well, obviously that doesn't meet Sydney Water's needs. So we need to be very careful and very clever in how we build that energy management system. And that's why we've selected Bondi as a very good example of one of these 680 sewage pumping stations that Sydney Water has around their network.
And so how did the experiment unfold? What did you try and what surprised you?
Well, so far we're at the stage where we've characterised what the pumping station actually needs. So that's the first thing you need to, when you're building a system, whether it's for your house or whether it's for an application like this, you need to say, all right, well, what do we actually need? And for houses, it's very, there's lots and lots of information out there. There's all of these profiles that say, are you a family with kids, a dog? Do you have a pool? Is it stay-at-home parents? Is it, all these sorts of things, and you can get a very good understanding of how they use their energy and how much energy they need every day. For a pumping station, there's not a whole lot of information out there. So what we had to do, and what we're presenting here at Ozwater, is looking into, okay, what does a pumping station actually need every day in terms of the energy, so how much energy it uses over the day, but also instantaneously how much power it needs. And that's really some very critical information that we can then use to build that energy management system, that we can then use to drive the design of the sodium ion battery modules in order to make sure that we're actually fulfilling this Bondi pumping station need, and then of course looking further ahead, fulfilling Sydney Water's other pumping station needs.
So the experiment, is it unfolding as you had thought it might? Have there been things that have popped up that were unexpected?
Well, yeah, because we were sort of moving into uncharted territory, we didn't really have a good handle on exactly what the needs would be. And it's quite interesting that a pumping station has very different needs to a house. So the energy storage and the energy management and the energy generation has to be vastly different to a system that you would simply, just put on your house. So things like we have a very high power draw. So when these sewage pumps start up to pump sewage out of the holding tanks, we have a very, very high power draw. But over the day, the pumps might only turn on for sort of 15 minutes, 20 minutes, and then stop for an hour, and then turn on for another 15 minutes, then stop for 3 hours. And so it's not so much about a continuous draw as these very sharp events. And so we need our system to be able to handle that. Whereas in a house, you've got the lights on for 4 hours, you've got a TV on for 5, it's a very sort of low and slow burning sort of energy usage. Whereas we found through the research that we've done here that the pumping station is much more sort of short, sharp bursts. And so that, as I said, drives the way that we design everything else to meet those requirements.
And how confident are you that you will be able to design something that does meet those requirements into the future?
Well, I think that having that knowledge now allows us, because we have Sydney Water so tightly integrated and our manufacturing partners so tightly integrated into this smart sodium storage solution project, we can really iterate on the needs of Sydney Water and the needs of the application, so that we design from the very first principles. We design through our energy management system, our sodium ion battery modules, exactly to fit the needs. And I think that we're on track to do that, and to be able to demonstrate this in the Bondi pumping station very soon.
And so, Harry, this is just one site. If this all goes well, what would be the plan for Sydney Water?
I think Sydney Water will have to consider the use of a sodium-ion batteries for other pumping stations. This is a highly active pumping station in a very well developed area with a lot of population that changes over the year because of the touristic season and all that. So there will be other opportunities where you have to install the sodium-ion battery in remote areas, and that's where that could be one of the niches for Sydney Water where they could use the new technology. Something that Jonathan didn't mention is that the beauty of the project is that it's combining research, basic research, with the manufacturers that are producing a piece of equipment that we can test in the field. And that's something unique in this ARENA project.
It's a fantastic collaboration. Well, thank you for coming in and telling us about it.
Thank you.
All right.
And with me have been Dr. John Knott, Associate Research Fellow at the University of Wollongong, and Dr. Heriberto Bustamante, Principal Scientist Treatment at Sydney Water. Thanks for joining us.